All right, Algebra 1, here we are. So today we're learning some tricky equations. So these are equations where things are coming up that we're not expecting. So here's your homework for tonight from the textbook. So don't forget to make the equation positive first. You always want your first term. Well, let's take it, what did we talk to? It's first that. So what could I do? Well, another thing that I want to do, I want to get all terms on one, and we get negative 15x minus 2. So we've solved one problem. We've got the other problem is still here. Because if we're going to factor it, we don't like to have the negative there. What can we do? We can multiply through the whole equation by negative 1. Whatever I do to the left, I do to the right. So watch. Negative 1 times negative 7x squared. Negative times a negative is positive 15x. Negative times a negative, positive 2. 0 times negative 1 is 0. Here by negative 1, you change all the signs. Okay, now I've got something I can work with. I've got to, what are we doing? We're doing by factoring. I've got to solve it. It's a trinomial, a is greater than 1. So magic box. So what multiplies to 14 and adds to 15, 14 will do that. So we make our box. We put x, 1x and 14x in there. Then we put x squared, ax squared, and c down here, 2. And now we're going to GCF, up and left. When we GCF up, says we can only take out a 1. When we go left, we can take out an x. When we go left, we can take out a 2. There we have. So our factors are 7x1 and x plus 2. I've still not done solving. I've factored. What do? Factor equal to 0. 7x plus 1 equals 0. X plus 2 equals 0. Subtract the 1. 7x equals negative 1. Divide by 7. X equals negative 1. On the left, right hand, here over here, subtract 2 from both sides. We get x equals negative 2. Please box in your answers and yours. There we go. It was a little tricky because we had to move things over, get rid of this negative, but there we have it. Well, let's do problem number 1, and then you guys will try the next two. All right. So here's the equal sign. Let's get everything. We're going to subtract m squared, subtract 4m, subtract 10. Subtract everything. So 2mm squared minus 4m minus 10. Everything cancels over there. 2m squared is m squared. Negative 7m and negative 4m is negative 11m. And then there is no constant over here. 10 equals a big fat 0. That's what we like. Now we look at it. It's a is equal to 1. So, right? M. What multiplies to negative 10 but negative 11? 1 and 10. Oops. Let's see. If I have to make one of them negative. If I make the 10 negative, then I 9, and that does not work. Let me just, when I get to a situation like this where I see it's not factoring, okay? This is not factoring. Either or I just can't solve it some other way. So let's look at it. Got this. Did I subtract m squared? Yes. And I subtracted 4m and subtracted 10. There's no math mistakes at this part, so what I'm going to just write is not terrible. So let's just do one more together since that didn't work so well. And sometimes that just happens. You just can't factor. We can solve it. What method we'd solve that on? We would solve that by, so another day. Here we go. Same situation. Let's get everything to the left. So I'm going to subtract 4x squared minus 7x minus 30. Minus 4x squared minus everything cancels on the right, and I get negative x squared, add those, negative 9x minus 20 equals 0. I don't like the negative 1. I get x squared plus 9x plus 20 equals 0. Simple factoring. I take, so it's just going to be x. What multiplies to 20 and adds to positive 9? That's easy. 4 and 5. So plus 4 plus 5. All right, so I'm not done though. I'm asked to solve. So set each factor equal to 0. 4 equals 0. Subtract the 4's. Those cancel. X equals -4. That is one solution. X plus 5 equals 0. Subtract the 5 and I get x equals -5. Think about this. I had a quadratic. I knew there would be two answers, and there are. So I'm good. Okay. You can stop the tape and try the problem on your own. Okay? Now let's go back. Once you've come back, let's go to the back side. All right, applications. Remember that the solution of a quadratic, if we're figuring on the last page, like you've got a quadratic, right? When an object hits the ground, that is the most quadratic equations we've come up against. Be sure to set your equation equal to 0 and factor to solve. These almost always have a GCF. Okay, let's see what we got. A ball is thrown straight up from a 128-foot building. Speed of 32 feet per second. The height of the ball as a function of time can be modeled as function, okay? So we're going to just draw a sketch. We know y is 128. So we know ball gets dropped off the building. Y-intercept is 128. We know it's going down. Okay, the ball is thrown straight up, down. So the question is, how long? Axis. This is a function of time, so this is the time, we'll call it in seconds, and a function of the height and the time, and we'll in feet. Says everything comes into foot. Will it take the intercept? I want to solve this by hand, so test, right? I know I can do this on the calculator. What do I do if I don't have a calculator? I equals -6t squared plus 32t plus 128. There's almost always a GCF. So the GCF has got to be -16. So let's factor out the -16. Y equals -16. And then what do we have left? T is 2t. 128 divided by 16. 128 divided by 16 is 8. So it's 128 divided by -16 minus 8. Okay? So this equation, I'm going to factor it. I've taken y equals -16. It's simple factoring. There, a is 1, so it's going to be factor with a t. Now we're going to look what multiplies to -8 but adds to -2. Simple factoring tree. Well, 2 and if I make the larger number match, and there we go. It multiplies to -8, -2. So I put in plus 4. Okay? So now what I'm going to do is I'm going to set each factor equal to 0. And at this, I don't have to worry about this. If you take out a coefficient, you don't have to worry about it. These will, so you set each factor. 2 equals 0, t equals -2. T minus 4, 0, t equals okay, so at -2 seconds, okay, this would have been a solution. Okay, is that relevant to our situation here? This isn't real. It's not really happening because we were here at the beginning. We can't go back. So all that matters is this, which is 4, right? So not valid. And so how long will it take to 4 seconds? It will take the ball 4 seconds to hit. Okay. Next problem is hit straight up in the air, feet per second. Notice that's coming here. The height of the ball can be modeled by this function. It means that the c value 0. Sketch, sketch, sketch. Draw your sketch. Label your c's. So we know where state is modeled on the y-axis, x-axis. All right. All right, so the ball is going to start on the ground, 0. So the y-intercept is 0, okay? That it's going down. So it's hit straight up in there. So it goes up, and then it comes down. When will the ball hit the ground? That's what is the x-intercept. We know one x-intercept is right there. Okay, so we got y equals -t squared plus 64t. Okay, and what we're going to do is we're going to factor out the 6. Divide out the -16. We put it to the left. That's what we do when we factor something out. What do we have left? We have t squared. 66 is going to be -4t. All right? So what are we going to do this? There's such a thing as greatest common factor. Okay, so what we do here is we say that this is negative 16, factor out a t times t minus 4. If I take a t, I have t minus 4 left. Okay, now I'm going to set them equal to 0, and this is here, you'll see in a minute. So it's the first one, negative 16t equals 0. The negative 16 and you get t equals 0. And then we take the next one, t minus 4 t equals 4 equals 4. So the question, when will the ball hit the ground? 4 seconds. The ball will hit the ground in 4 seconds. All right, last one. Ball is thrown straight up from the top of the 288-foot building. Speed, there's the initial height, initial speed. Okay. I hope you're asking yourself, why keep popping up? That's what you should be asking yourself. I'm not going to talk about that on this video, but here we've got time in seconds and height in feet. Ball is thrown from the top of a 288 foot, there it is, 288 feet, with an initial up and comes down. When will the ball land? We know how to do this. Y equals negative 16 plus 48t plus 288. Okay, so I'm going to try to divide out the 16, that GCF. Take out the negative 16 and see what happens. So I get t squared, and then divided by 16, turn works better, and I get minus 3. Because remember, it's 8 divided by negative 16, so negative 3, and then 288 divided by 16, negative 16, is negative 8. All right, a positive divided by a negative is a negative. Okay, well now we got y equals negative, factor, 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 factor. It's a is 1, so it's simple factoring tree. And we say what multiplies to negative 18 adds to negative 3, 6. These signs have to match. It'll multiply to negative 18. It'll add to negative 3. But plus 3, negative. We're not done yet. We've factored it. We set the factors equal to 0. T plus 0, negative 3, t minus 6 equals 0, t equals 6. So what that means is this is irrelevant. Back in time, can't do it. This is what's relevant. 6 seconds, the ball will hit though. The answer is 6 seconds. After 6 seconds, the ball the ground. All right, so those are our lessons for today. Go ahead and we'll hand it in and it will be graded. Okay, all right, I'll see you next